Using JDBC in this an example of interacting with a database. Okay, so we're going to create a small data model, relational data model, and then we're going to try and use JDBC to connect and interact with these database. So first of all, we're going to create a server project, a Java 2EE server project, using the Spring Boot framework. Spring Boot is a very opinionated version of Spring MVC. I don't know if you've used Spring MVC. Spring MVC is fairly complex to set up. Spring Boot allows you to really quickly have some up and running Spring MVC Java application that you can just run it from the command line and it just works. So let's demonstrate on how that might work. Let's see. So we are here in the fall 2019, and we're going to create a project. And the project. Let's see. Let me put this right here next to each other. So it's we're going to use the command line Spring init, which you can install if you're on a Mac. You can install it using brew, or you can go to this URL to install it yourself. Or if you look for Spring Boot command line interface, you can install it on your machine. So I already have it installed on my machine, and I'm just going to create a new app. So Spring init dependencies web my app. So it'll be Spring init dependencies web, and I'll call it let's see, CS5200 fall 19. This is a server, and it's a Java server, as opposed to a Node.js server, which we'll take a look at a little later. So that's gonna create a boilerplate application for us. And if we go in there, so this creates a directory. It creates this this Java project. Notice that it has a POM file in there, pom.xml, which describes the dependencies of this project. Right now, it says that it's a Spring Boot framework application, the Java version, and it's all ready to be run as a server, as a web server. We can just try it out real quick if this actually works, and we can create we need to create a new directory under source, under main, a web directory, and we can create a file in there in the source main web app. We'll create an index file, and we'll say h1 welcome to CS 5200 fall 2019. And we can compile this into an executable, and would be using Maven clean install. So Maven is a build tool that reads your POM file and downloads any dependencies, any libraries you have declared in there, compiles any Java code that has in there, and it packages all into one single jar file, into a single executable file. It will create a directory called a target directory, where it will put the built executable file. There it is. So it has created this new directory that was not there before target, and we can just run it by just saying Java jar target and CS 5200, and that jar file contains our server. It boots up, and by default it listens on port 8080, which we can visit with our favorite browser, localhost 8080, and we can ask for the index file we just created, right, which says welcome to CS 5200 fall 2019. So anyway, so we're not gonna use much this. What we really want to focus on is how do we connect this to a database, right? So let's head over to MySQL Server Let's create a schema for ourselves and maybe a couple of tables, and then see how we can interact with it. So let's head over here and let's create a brand new schema, and we'll call it CS 5200 Fall 2019. And in here, we'll create a really simple table for now. Let's see. For now, we'll create a table that can keep track of our favorite movies. So let me grab this table, movies, and let's go back to MySQL and let's create that table right here. Let's run this, and it didn't like it. What? Oh, okay, I'm in the wrong. Okay, I'm double clicking on the schema so that the default operation will be on that default schema. So let's try it again. Use CS 5200 Fall 2019. Use what are correct table efficient. There can only be one auto increment. Oh, sorry, ID. Thank you. I knew that. Just checking if you were listening. All right, there we go. So we have that table, and we can maybe create some records in there. We can select it. Obviously, there's nothing in there just yet. And so let's just create a couple of tables here. So this will be maybe aliens, maybe Titanic, Terminator 2. And so we'll insert those 3 records, and it didn't like it. What am I missing? IMDb does not have a default value. Oh, okay. Did I declare it not null? Okay, so notice that not null, right? That's a constraint we put in there, so it's not allowing us to add here. It's not optional. So let's create a couple of IMDb's. Apply. Let's see. What am I missing? Oh, did I miss one? Not null, default null. What am I missing? Value, IMDb, movie, apply. Okay, all right. We have a couple there, so if we select again, we have that data. Fine. All right, so we have some data there, and we'd like to be able to connect to it. So what we're going to do on the Java side, what we're going to create is some model, a Java model that we can map to this relational database, right? So to model it in Java, we're going to create a class of the same name, right? So let's do that. We'll create a Java class called movie, and here's one of the first challenges of mapping between an object world and the relational world, right? In the relational world, notice that the naming convention would be that this is a collection of movies, right? A set of movies, and so we call it using plural, right? That's a common naming convention in relational databases. But since in the object world, a class typically doesn't refer to any collection of movies, right? It's just a template for instantiating a whole bunch of movies. So that's one of the first mismatches between these two worlds, right? And that's one of the things I like to discuss about what we sometimes refer to as the impedance problem, right? That things that are implemented in the relational world don't necessarily map nicely into the object world. So let's create a class, in our project. We're going to open the project we just created, and let's see, it's under Januzzi, CS5200, 2019, fall, and there it is. So it says open that. It's going to parse it and make it look a little prettier. There we go. In the source, in main, in Java, there is one single class that gets created for you in the boilerplate project. Right. This is the entry point of the entire application. Notice that it's a class and it has a static, public static void main. Right. So this is the entry point of the application. Right. This is what starts the server up and running, listening at port 8080. But that's it. It doesn't do much. It just does. It just says run the demo application, and that's it. Okay. Obviously, there's a lot of magic happening behind that, and we're going to leave that magic as is. Part of that magic, right, is that any Java classes that we want to map or somehow mapped to a database, right, needs to be under the same package. Okay, right? It's part of the magic. Not all classes need to be mapped to a database. Some classes obviously are just data model business logic that might be part of your running application. Only perhaps a subset of your classes might be mapped to some tables in the database, right? That where you read records in the database and you instantiate instances of these classes that are somehow mapped, right? You keep track of what's in the record, and then you have an object representation of that record. Yes? So all those that you intend to be mapped to Java classes mapped to databases need to be under this package. Otherwise, you would have to register them and let them know which ones you want to map and whatnot, right? So it's better to just stay in the magic. Anything that you declare outside, of course, you can declare your own packages, but it won't necessarily be mapped directly immediately, okay? You would have to declare and register them. So I'm going to stick with the magic. I'm going to put here a new class, and I'm going to call it the movie class. And this movie, I'm going to have this more or less a one-to-one mapping of the same fields that I have in the database. I'm going to map it to my Java class. So I'm going to have ID, IMDb, title, plot, and poster. Yes. So here I might have a private int ID. I might have a private string IMDb ID. I might have, what else do I have? The title, the plot, and the, what else? Poster. Okay. So here's yet another idiosyncrasy that doesn't map directly one-to-one between Java and the relational world, is that in Java, typically the naming convention is camel cased. Okay, Java is case sensitive, right? So IMDb and IMD ID like that, it's two different things. Whereas in the relational world, they are not case sensitive, right? So for instance, even though I use IMDb ID here as a capital, right, capital I, right, MySQL doesn't really care, right, what the case is, right, and typically the naming convention in MySQL would be that if you have compound words, you would use an underscore between them. Yes. So now you have naming conventions that are different in two worlds, right? That one is case sensitive, one is case insensitive. Not a big deal, right? But certainly it's something to keep track of, right? If you're going to be doing mapping between these two, and know that that a particular field maps in the relational world that maps to something in the Java world. Yes, okay. Other than that, it's a pretty straight map between the two worlds here, right? Let's also generate a couple of setters and getters here. So we'll generate some setters and getters for all of them. And probably we'll also generate a constructor a no argument constructor plus an all arguments constructor. So let's generate one with all of them, all the fields. Okay, so we pretty much have everything we need, right, to work with this. Excellent. There we go. Excellent. The other thing here is that we're going to use a best practice, right? That's common in industry, is that whenever you're going to go and hit a database and start communicating with database from your code, it shouldn't be just from anywhere, right? Because should I just whenever I want to talk to a database, should I just establish a connection and start talking to it from anywhere in my code? Typically not, right? Typically what we want to do instead is encapsulate all data access into a few dedicated modular classes that their only responsibility is to talk to a database, right? So that you create a single point of maintenance so that if you ever need to modify any of that communication with the database, you have a single place where you can update that, and that's it, right? Instead, these data access objects, the DAO, provide an interface to the rest of the application, a high-level interface to the rest of the application, so that the rest of the application doesn't have to care on what, how is it getting the data, right? It shouldn't care that it's one vendor versus another vendor. It shouldn't care that it's a relational database or non-relational database, right? The rest of the application would be agnostic to how the data is being accessed. Make sense? So a DAO, the data access object, encapsulates all these aspects. Okay. The other aspect is that typically data access objects implement a design pattern called the Singleton design pattern, meaning there's only one instance of this object for everybody to use throughout the application. Okay. So the DAO encapsulates two design patterns. One is the Singleton design pattern, and also the DAO is also considered to be a design pattern, right? It's a best practice, very, very widely used. So let's create a DAO. And we'll say new Java class. We'll call it the movie DAO. Also, typically the DAOs will be broken up by how is it that you're exposing the data model in the relational world, right? The most common way is that there will be one DAO per table. Okay, so if there's a movie table, there will be a movie DAO, right? But oftentimes we might have DAOs that might go across tables, right? That it might be an association that is associating movies with users. Maybe you're like a review, right? That is an association table that actually joins two tables, right? That grab like a view. There might be a view even associated to a view as opposed to a table. Yes? Yeah. So let's keep it simple. So the movie DAO is going to be a singleton. There's different ways of implementing singletons in Java. This is a trivial way of implementing a singleton. So a singleton means that we need to guarantee that there's only one of these instances going around, right, for the rest of the applications. Yes? And one way to guarantee that is to make your constructor private, meaning nobody can just go in and just instantiate movie DAO, right? We want to control that, right? We want to be responsible for that. And instead, we're going to expose a public API that allows us to control the instances of this DAO, right? If you want an instance, you need to ask for it, okay? And what we'll do is that when you get an instance, if it doesn't exist initially, we'll create one for you, right? If it already exists, we'll just give you the one that already exists, right? So I'm guaranteeing there's only one of these anywhere in our application. Yes. So here's my instance of the movie DAO. It's a static, right? It's going to be the same instance for the entire application, and you need to go through this gate, right, to ask for an instance. If it doesn't exist, I'll create one for you and I'll return it. Otherwise, you'll always get the same instance. Anybody who asks for the instance will always be working with the same instance. Make sense? All right. Once they have the instance, they should be able to use this DAO to talk to the database, right? And typically the things that we want to be able to do with the database are the 4 or 5 operations are most common, right? We need to be able to create records, right? We need to be able to retrieve records. We need to be able to update records, and we need to be able to delete the records, right? The 4 CRUD operations, right? So let's do that. Here are a couple. I'm just going to copy them here. I'm just going to paste them there. So there it is. So the first one is the create movie. And again, all these methods, what they're doing is that they are exposing the data model. They're hiding the idiosyncrasies on how actually a movie is created. Right? Instead, it's exposing this nice signature that says create movie. Give me a movie object. I'll handle the creation of the movie. Don't worry about it. I'll create it for you. And same thing with find all movies here. I'm going to just for now return null. And find movie by ID, return a null. Right, there's update movie, and there is delete movie. Okay. And let's go over just real quick. So the create movie, like it says, presumably it's going to do an insert into a database. Yes. It'll be passed an instance of movie IDs and IMDb's and titles and whatnot, and presumably it'll be doing an insert. Then in the find, these are my two read operations, and these are the most common read operations. One, give me a list of all the records, and the second one is give me a particular record. Right? Obviously, you can create other finder methods. Again, this is a very common naming convention when building DAOs. Right? The create always starts with create, followed by the data type of whatever it is that you're creating. Right? Find all movies. Again, that's a very common name. Find all whatever. Okay. And there's also find whatever by ID. And then there's other finder methods that you can create yourself, right? Maybe you say public movie find movie by title, right? Things that you get the title, right, and then you return something, right? Typically, this one you provide at least a finder by a primary key, at least that. If it's a compound primary key, then you would have to provide all the fields for the compound primary key, plus any other non-primary key finders, right? Like a title, a rating, a plot, actor, director, whatever, something that not necessarily is unique. Make sense? Then update typically provides the unique identifier primary key of what movie are you updating, and then the new values for the movie. And then delete provides a primary key to remove that particular record. Make sense? All right, so those are the most common ones. So let's build just a couple of things here. Let's do a find all. So let's implement find all. So let's do a find all. So here, right before here, I'm going to just declare a couple of constants. So this should be a constant. So find all movies, and that's the string. Oops. Okay. And the find all movies would use the JDBC code to actually return the movies. So let's copy that. I'm going to first instantiate a list of movies, an empty list of movies, array list. We're going to grab the connection. I'm going to declare the 3 things that I need to connect to a database, right? So the connection, the statement, and the result set. I'm going to grab that. And I'm Java SQL. Connection is Java SQL. Yep. Let's make sure that those are imported correctly. Connection, result set, and statement. Very good. Once I have that, We're going to ask for the MySQL driver, right? We ask for the MySQL driver. It's going to complain, saying that this can throw exceptions. So we're going to unhandle, blah, 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 add exception. No, I don't want that. More actions. And surround, we're going to surround this with a try catch. Okay, there it is. And then once we've registered the MySQL driver, we're going to connect to the database. So the connection is going to be driver manager, get connection. This also throws exceptions. So let's maybe add a catch clause. There we go. There's a SQL exception. And our URL will be connect to the local host, listening at what port? Let me see what port. Home 3306. 3306 is the default port for MySQL. The database is this one, right? It's this one right here, CS5200 Fall 2019. So that's CS5200 Fall 2019. Usernames, I believe I have already one with CS5200 and CS5200. Very secure. And once I have the connection, I can create the statement. I can execute the results, the query, which is find all movies. There it is. And then I can start iterating over them. Right? I can do a while loop over this. Right? And as I iterate, I can read the ID from the results dot get integer. The field, I believe it's called ID. We can grab everything else, right? So IMDb ID is results dot get string, and it's I believe it's also called IMDb ID. And let's get the title. And it's title. What's complaining about this ID? What is it? Variable ID is already defined. Oh, do I have an ID somewhere else? Oh, I have ID here. Oh, I was implementing find all movies. Let me move this over to find all movies. Find all movies. There it is. There we go. Okay, now I'm reading the ID. Once I have these, I can instantiate a movie and say movie. If I type it right, movie, new movie. And I believe I can pass in the ID. I can pass in the IMDb. I should be able to pass in the title, no plot, and no poster. There we go. Right. Once I have that, we can add the movie into our list of movies. So movies dot add movie, and we should be able to just return the movies right here. Return movies. Right. Everybody good? All right. Excellent. All right. So let's try it out. Let's see. Can we run it from here? Movie DAO, movie DAO, get instance, and we can say DAO dot find all movies, and list and assign it to a list of movies. And then we can just iterate over this, right? So for movie, and movies, display, system, and that out, that println movie dot get title. Okay. All right, let's see if this blows up. I don't know if it's going to work. Let's try it out. So we're going to compile again. And let's run it. And it failed. Let's see. URL class, yada, 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 yada. Okay, can't find that driver. Okay, probably because I never downloaded it. All right, so let's download that driver. Let's do that. So to download the driver, right, what we're going to do is that we're going to declare that driver as a dependency. Right, so from here, notice that we kind of skipped this slide. So let's take a look at it. We can just copy that. And we can declare that dependency right here in our POM file. So there's our POM. And right here, right next to all the other dependencies, we can paste that. And let's remove that. Oh, I don't believe I need that. And I don't believe I need that. There we go. Now, depending on which version of MySQL you have, you might need to have a different version here, right? I have this version. Let's recompile. Maybe clean install. Oops. Test failures. Let's see. What's complaining about? Yada yada yada. Fail. Blah blah blah. URL data source is not specified and not embedded data source could be configured. Blah blah blah. H2 if your database settings. Oh, okay. So all right. So we need to configure something else. Something else additionally. Let's configure here. In the resources here, any resource that you're using, any database resources that you might be referencing, need to be declared in this properties file, which is currently empty. So I'm going to paste that in there, and we're going to point to the URL that the MySQL database that we are using. Same connection. This is what I was mentioning earlier, that that it was a bad idea to declare your URLs, your usernames and passwords as part of the source code, right? So that's what we're going towards, right? Where all those things can be declared and implemented outside of the source code, right? So let's let's do a localhost 3600, and the database is, what was it? CS 5200. Fall 2019. The database is username is CS5200 and CS5200. Let's see if this is what it was complaining about. Let's see, oh, it's a little better. What's it complaining about now? Main, blah, 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 nested, yada, 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 debug, SQL, time zone, yada, 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 server, driver, blah, 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 configuration, server time zone. Okay, so it wants to configure the server time zone configuration property, okay? Let's see, probably needs to be configured right here. Or maybe demo, edit configuration. Build. Oh, maybe at the command line? No, that's not it. Let me look it up just a second. My server What's the error? Server blah 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 blah. Okay, so let's copy that. MySQL blah blah blah. Okay, that seems to be the error. All right, let's add this to the URL. Oh, there it is. Server time zone equal UTC. Okay, that's the what it was complaining about that was missing. So let me grab that. And let's add that to here. Server time zone UTC. Let's see if that helps. Okay, so that looked like it worked. So let's try it out again. So it would be the Java jar. Server time zone, yada, yada, yada. Okay, so I think I need to also configure it as a command line option. So server UTC as a command line option. When I run it, so we can say -d server time zone UTC. Blah, 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 the server time zone, still complaining. Server time zone, SQL, MySQL, the new driver is deprecated of SQL, the server time zone EDT is unrecognized. I'm not using EDT, I'm using UTC. MySQL, the server time zone driver, blah, 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 is unrecognized. -d, I think that should have worked.